Had we finished number 2?
Yes.
Okay, so let's go on to number 3. Factor by... What's that?
The ID.
Oh, you need the meeting ID. I'm sorry.
Sorry.
657
Yeah.
795
Alright.
925.
Alright.
Forgot what I was doing for a second.
We'll take this a second to load up.
Yeah, that's fine. I don't think we had finished with number 2, and we need to. So let's go back and finish with it once you get logged on. There you are. You there?
Yeah.
Okay, let me blow this up just a little bit and then take a picture of it so that I can write on it. Alright, so what we had is this, 3x minus y. What I was saying was get rid of the parentheses first. So what happens when you distribute this? What do you get? Distribute the minus 4x times both terms.
We get minus 4x squared. And then minus 8x.
And I still have my plus 1. Okay? Now, remember what standard format is. Standard format is this. So, I want to solve for y. Which side should I put y on?
Which side?
Which side? The left or the right?
The left.
How about we put it on the right? Because if I move it to the right, it becomes positive, which is exactly what I want.
Alright.
So I'm going to put it over there. Now, that means I have to put all 3 of those terms on the left, which is fine. We're going to end up in standard format all the same. So what goes on the left side here?
Left side we get
Move each of those 3 terms to the left side.
4x squared minus 8x plus 1 equals y.
Well, now combine the 8x and the 3x that's over there.
Then it's minus 4x squared.
No, it's going to be 4x squared. You were right there. In other words, when you move these terms to the other side, you got to change their sign. That's the way to move terms to the other side. So it's going to be plus 8x, and there's already 3x over there, so it's going to be 11x. And then what's the number?
Minus 1.
Notice that is standard format. The fact that the y is on the other side of the equation matters not. What's important is that the y be positive y and all by itself. In other words, if you had this in standard format, and now I said, what is the vertex, or at least what's the x-coordinate of the vertex, what would it be? Minus b over 2a.
So that would be negative 11 over 8.
Yeah. And notice that it would not have been very easy to find the vertex in the original way that the thing was put. In other words, when I'm looking at this original equation, I got no idea where the vertex is. And it's almost impossible to figure it out unless you put it into some kind of standard format. Standard format being this, but there's also vertex format. I could have put it into vertex format with a little bit more difficulty, and then I would have been staring at the vertex. So either of these is a necessary skill. You want to be able to put a quadratic into standard format or vertex format. Now, factor that using greatest common factor. What's the greatest common factor?
Would that be 3x?
And what's left?
Then we have x squared minus 4x plus 7.
Good. And as you did each of those terms, you should be multiplying them back together again to make sure that they equal what you started with. In other words, that times that, that times that, that times that better be equal to those three terms. And it is. And if you check as you go along, then you'll pick up mistakes as you make them, and you won't have to figure out. In other words, the last thing in the world you want to do is have a problem that's got like 9 steps, and you get to the final answer and it's not right, and you have no idea where you made your mistake. Whereas if in each one of those steps you're always checking, then you pick up the mistakes as you make them.
Yeah.
So number 4, how does that factor?
Multiply two vectors. We have x. Add the set and multiply x plus. So x in both ends. And then plus 4 plus 3.
Now multiply those two together.
That equals 12.
No, I mean, it says then multiply the two factors to expand to make sure you get what you started with. That's what factoring is undoing the multiplication. So once you undo it, you should be able to redo it and you get exactly what you started. Foil this, or do it every term by every term. What do you get?
You get x squared plus 7.
Well, you can do it term by term. I would almost rather you see you do it term by term.
Okay.
In other words, I know you can see that, so you know what it's going to be, but that's not the way you multiply them back together again. You multiply them back together by multiplying that times that, and then you multiply that times that, then you multiply that times that, and then you multiply that times that, and you add all 4 terms together. So let's do that. Your first term was x squared. What's your second term?
3x.
What's your third term?
4x.
Plus 4x. And what's your last term?
12.
Plus 12. You need to separate these by a plus or a minus sign. Because if I just write 3x like that, it doesn't mean anything. In fact, if it meant anything, it might mean multiplication. So I cannot ignore the plus sign if there's supposed to be one there.
Yeah.
Now, you can always combine those middle 2 terms. And you rarely have terms that, in other words, that first term and that last term comes from the F and the L of FOIL. So we did multiply them back together again and we got that. So that means we factored it properly. And that was the whole problem, was In other words, once you factored something, if you want to know whether you did it correctly or not, you kind of have to multiply it back together again.
Yeah.
Number 5, what are the solutions to the equation?
What are the solutions to the equation? Are we just expanding on it like last time?
No. Here's the thing. In algebra, if you have two things multiplied together, there's one thing, there's another thing, and it equals 0, that means each of those things could be 0. In fact, one of them has to be 0. That is the most important rule in all of algebra. If you learn one thing from algebra only, that should be it. If you're multiplying multiple things together and you get 0, one of the things has to be 0. So the way I solve this is I set each one to 0 and then I solve. So what's x equal to here?
X is equal to...
Solve that equation. X minus 3 equals 0. Solve it for x.
X is equal to minus 3.
No, it's not.
Oh, positive 3.
Now solve the next one. X plus 1 equals 0. In other words, this term here.
X is equal to minus 1.
There are your two solutions.
Alright.
That's how you do it. In other words, always remember, that's the whole reason we factor. In other words, if I go up here to this quadratic up here and I set it equal to 0, I have no way to solve that. When I have a quadratic equals 0, I can't solve it. But if I can factor that quadratic into two things multiplied together that are equal to 0, now I can solve it. Now I just set each one equal to 0 and it's solved. That's the whole reason factoring is key. How about number 6?
Number 6, would that be x is equal to 2.5?
Good. I prefer this answer. And what else?
4.
Okay, good. Now, let me scroll down here a little bit. Find the vertex of that quadratic. You know quadratics are always parabolas. So they either look like that or they look like that. Well, the most important point you can possibly talk about on a quadratic or a parabola is that vertex.
Yeah.
So how do I find the vertex of this?
Find the vertex. I don't know how to do this.
Let's start with the x-coordinate. Because the thing is in standard format, let's do it the easiest possible way.
Alright, minus b over 2a.
Good. Fill it in.
Minus 9 over 6.
Which is the same as minus 3/2.
Yeah.
And that's only the x-coordinate of the vertex. What's the y-coordinate of the vertex?
Hold up, I need to do some math here.
Okay. Tell me what you're doing and I'll write it.
3 times minus 3/2.
Always use parentheses because you're squaring that. And you are squaring the minus sign.
Plus 9 times minus 3/2.
And I caution you about doing the arithmetic early. Always write it out like that. The first step in simplifying is get rid of your exponents. What's minus 3/2 squared?
Minus 3/2 squared is, we just square everything in the equation. And the fraction.
You square top and bottom.
I did 4 over minus 6.
What's 3 squared?
3 squared is
3 times 3.
that is 9.
Okay. What's 2 squared?
4.
Now, the fact that that minus sign is squared means that it disappears. When you square a negative number, it becomes positive. So the answer is 9/4 at this point. Now, let's do the rest of it. How do I simplify this part here? What's 9 times minus 3/2?
Okay, get a calculator. 9 times minus 3/2.
Uh-huh.
9, I don't, it's just 9 and minus 3/2.
What's 9? The only thing you need to know is what's 9 times 3?
Which is 27.
Okay, so it's minus 27 over 2. In other words, the result of that operation is minus 27 over 2. And we were adding that term, which means that a plus and a minus together equal a minus. So that takes care of the second term. Now minus 12. Okay, now simplify this. What's this first term equal to?
3 and 9/4.
No, that's 3 times 9/4.
Yes.
What is that?
Hold up.
I do not want a decimal answer. I want a fraction answer.
Hold up, don't call me calculator. That equals 108.
No. Again, what's 3 times 9?
27.
So it's 27/4, that's the first part, minus 27/2 minus 12. Now, how do I do this math here?
I need to double the 27.
Okay, so that becomes 54/4. Now what's 27/4 minus 54/4?
That is minus 27/4.
Okay, and then minus 12. Let's get an answer entirely in fourths.
Hold up.
So how do you subtract 12 from that?
Well, we can put 12 over 1.
Now we need a common denominator. It's got to be 4.
Yes, then we can multiply that by 4.
Okay, so that becomes 48 over 4. That's 12. And now do this math. What do you get?
Minus 75/4.
Minus 75/4, which cannot be reduced. That's the y-coordinate of the vertex. Now, that might have looked like a lot of work, but that was the simplest way to get it.
Yeah.
In other words, there is a formula for the y-coordinate similar to b over 2a, only it's much more complicated and nobody remembers it because you don't need it. In other words, once you solve for the x-coordinate, plug it in and calculate what the y-coordinate is. The only reason this was relatively difficult is because we had negative fractions and we had a lot of arithmetic to do here. and you're stale on your arithmetic, which is not a good thing to be. You're stale on your arithmetic, you're going to have a lot of problem with algebra, because you've got to be able to take that and turn it into what we did. And a calculator isn't always going to help. It really isn't. A calculator may turn that into a decimal, probably would. Do you know how to take a decimal answer and turn it into a fraction?
I do not.
Well, that's the problem with depending on a calculator, is that you have to know what fraction that is. That turns out to be 18 3/4 minus 18 3/4, which is minus 18.75. This is what your calculator would give you, and that actually might work for an answer if your teacher accepts it. It's still, you got to be able to know how to do basic arithmetic, and that's all this is. Doing it without a calculator is basic arithmetic.
Yeah.
All right, let's go on. That was 7. Transformations of functions. Let me test you on this by making some up.
Alright.
If I have a parent function,
Yeah.
we'll start with a simple one. Now what I'm going to do is I'm going to give you transformations of this function, and I want you to tell me what the transformation is.
Alright. Isn't that just, subtracting 1 and then y?
Can't hear you.
Hold on, let me see, because I know this.
Okay.
I know these.
Well, let me get you started on this. There's 6 of them. So
Yeah.
that's a vertical reflection.
Oh, yeah.
And I call it a vertical reflection. Most people say it's a reflection over the x-axis. But you'll see why I call it a vertical reflection in a second.
Alright.
What is this?
Is that a vertical stretch?
Okay. And what is this?
As a vertical translation.
What is it?
It's a vertical something.
Shift.
Vertical shift, yeah.
Okay, now let's look at the horizontal ones. The reason I call this a vertical reflection is that negative sign is outside the function. It's a vertical stretch because that 2 is outside the function. And it's a vertical shift because that +1 is outside the function. Now let's go look at horizontal stuff. If I have this, that's inside the function. What is that? A horizontal what?
Horizontal is that a reflection?
Which means it's reflected over the y-axis, not the x-axis.
Yeah.
Now, if I have this, what is that?
horizontal stretch.
It turns out that when you're talking horizontal, it goes the other way. That's actually a horizontal shrink.
Oh yeah, okay.
And it would be a stretch if this number was less than 1.
Okay.
So the vertical stretch and the horizontal shrink are both when the number is greater than 1.
Yeah.
They're opposite one another. In other words, a vertical stretch tends to be very similar to a horizontal shrink. But what they share in common is that their coefficient is greater than 1. And finally, the last and only thing you can do is a horizontal shift, which again is inside the function. All my horizontal things are inside the function, all my vertical things are outside the function. So that's all you really have to remember. You really only have to kind of remember 3 things, not 6. Each of these 3 things are outside the function, therefore they're vertical. Each of these 3 things are inside the function, therefore they're horizontal.
Okay.
All right, let's go back and look at... So you can identify the transformations. Well, let's skip to 9, merely because 8 is not a transformation problem, and we just talked about it. So, go from left to right. What's the minus sign do?
9.
What's that? Yeah, on 9a. First of all, tell me what the parent function is.
The parent function is f of x equals x squared plus 5.
Nope, just x squared. Plus 5 is a transformation. The minus sign is a transformation, and the 1/2 is a transformation. But everything else is the parent function. Now, I don't call it f of x because f of x is the transformed function. So I call it g of x. Now let's talk about what this minus sign does. What is that? So I'm going to erase the parent function. And that's not enough. There's 2 kinds of reflections. There's over the x-axis and there's over the y-axis.
On the y-axis.
Is it inside or outside the function?
It is outside.
Does that make it vertical or horizontal?
Oh, that makes it vertical.
A vertical reflection, picture it. That is a reflection over the x-axis, not the y-axis. In other words, you're taking that image and you're flopping it vertically. Okay? So, first thing we're doing is reflecting over x. What's the 1/2 do?
The 1/2 is a vertical shrink.
Good. Vertical shrink because it's less than 1 by a factor of 2, but we'll just leave it at that. And finally, what's the plus 5 do?
It is a vertical shift.
Good. Now, you'll notice that shifts do not, and you have to follow that with up 5. Because first of all, vertical shifts can be up or down, and they can be by any amount. So you need all 4 of these lines to answer that question.
Yeah.
We have 3 transformations for number A. Now, number B, what is the parent function? If you don't know the parent function, it's awful hard to figure out the transformations.
True.
Take away anything that looks like a transformation and tell me what's left.
We have x equals square root of minus x.
No, that minus sign is outside the function. There's the parent function. G of x is equal to the square root of x. Now, unfortunately, I have a 5:30 that I got to go to, Nick. So we'll have to quit here. Apologize for some of the technical errors that we had, but I will talk to you next week.
Alrighty.
All right, bye-bye.
Bye-bye.